7 2 sum 2. Input array is sorted. So it's given a one index array of integers, numbers that's already sorted in non-decreasing order. Okay, now this is the first important thing: sorted in non-decreasing order. So that means that it's arranged in ascending order, right? Find two numbers such that they add up to a specific target. So we're given a target, and these two numbers have to add up to this specific target. Okay, let these two numbers be this number as index 1 and this number as index 2, where 1 is less than or equal to index 1 and index 2, and it's less than or equal to the numbers at length. Okay, return the indices of the two numbers index 1 and index 2 added by 1. So we're not just returning the indices, we're returning the indices plus 1 as an integer array of length 2. The tests are generated such that there's only one solution. So this gives us so this gives us, like, this makes the problem a little bit easier, right? And you may not use the same element twice. Great. Your solution must only use constant extra space. Okay, so the most important things in this question: number one, the array is one indexed. Great. It's sorted in non-decreasing order. Great. We're supposed to return the solution with the index plus 1. That's another one. And the tests are generated so that there is exactly one solution. Great. And we don't have to use the same element twice. So we can't do 2 plus 2, for instance, or 7 plus 7, whatever. It has to be one element at the same time. And once we get the solution, we know we've gotten the solution and we jump out of there. Great. So, and they pulled another hiccup, right? They said your solution must use only constant extra space. So we can't have we can't have a space complexity of anything that goes beyond O of 1. So in the examples, we have 2, 7, 11, 15, and the target is 9. And the two elements, or the two numbers, 2 and 7, when you add them together, they give you 9. But this 2 is at position 0, so 0 plus 1 is 1, and 7 is at position 1. 1 plus 1 is 2, and that's what we return. Great. And then we have 2, 3, 4, and the target is 6. 2 at position 2, and 4 at position 2, right? So that means we return 1 and 3. Great. And then we have minus 1 and 0, and the target is minus 1, which gives us 1 and 2 as well. Okay, so I think the problem is pretty straightforward for the most part. Okay, so what do we know about this problem? We know that the array, it's an array, one indexed array. We know that it's sorted in non-decreasing order. We know that we are supposed to return our output by increasing by 1. And yeah, so I think that's enough to solve it. So, okay, the first time I read this problem, I was like, okay, yeah, there's a way to solve this problem. Why not? When I'm at 2, I have like a fast and slow pointer. So when I'm at 2, I keep the pointer at 2, and I have a target of 9, right? So all I have to do is to check for maybe 9 minus 2, which is 7, and then I move my pointer to the next one for where I get 7, right? And in this case I actually get 7, so that's just going to be 2 and 7. But what if I have 2, 3, and 4, like in the case of the second example here, and my target is actually 6, right? So I have my first pointer at 2, and then I keep the 2, and then my fast pointer moves to the next one, checks 2 plus 3. Does it give me 6? It doesn't give me 6, so my fast pointer moves one more, and then checks, does 2 plus 4 or 4 plus 2, does it give me 6? It gives me 6. So because it gives me 6, I return 0 plus 1, that's 1, and then and then 2, right? 0, 1, 2. 2 plus 1, that's 3. So I return 1 and 3, right? But if I did this way, my constant space, will actually be O of 1, but my time complexity is going to be O of n squared. And well, we could do better. We could do better because of the fact that they told us that the array is sorted in non-decreasing order, which means it's sorted in ascending order, right? So what that means is that we could have a pointer here. Let me actually try to explain this better. So we could have one pointer here starting from the beginning and another pointer starting at the end, right? Great. Now when we have 2 plus 4, 2 plus 4 gives us 6. Now this particular solution is easy because at this point we just return this index here and plus 1, and then this index here plus 1. So this is actually an easy solution. But what if we did 2, 7, let's actually go with something like this, and 15, right? And our target here is 9. Now when we have the first pointer at the beginning of the array and the next point and last pointer at the end of the array, and then we check 5 plus 2, 5 plus 2 is 17, and 17 is greater than 9. Now because 17 is greater than 9, what makes more sense? Do we increase this part that we know it's in ascending order, right? Do we reduce this part or do we increase this part, right? It makes so much sense to reduce the one that is like, the higher side, right? Because when we reduce this part, when we reduce the faster pointer, we have 2 plus 11 now, which is going to be 13, right? Which is less than what we had initially. We had 17 initially, now we have 13. Wait, but 13 is still greater than 9. And because 13 is still greater than 9, we still reduce the right pointer a little bit more. And now we have 2 plus 7 and it gives us 9, and then we return that, right? Is there a guarantee that we'll always have a solution? Test generated such that is exactly one solution. There's exactly one solution, but by certain non-decreasing order. I don't see that guarantee here though. But is it possible for us to have an empty array? It's not possible for us to have an empty array, so we don't even need to bother about that. All right. So there's a guarantee that we'll almost always have like at least 2 numbers in our array, which is great. Now, so let's try this one more time actually on well, technically if we have -1 and 0. Now when we have -1 and 0 and we start our array at this point here, and then we have the next pointer on the last one here, right? Now when we check -1 and 0, it gives you -1, which is a target. So we just return the indices plus 1. So I hope that solution made sense. But we're going to code it up and you're going to see what I mean. You know what? Let me actually just call this left, and let's start from 0, and then let's have the right pointer and let it start at the numbers dot length -1. Numbers dot length -1, and then we have to decide what if on the off chance we don't have something getting returned. We'll just return an empty array. So what do we need to do now? We need to check that because they said we should make sure that we don't repeat an element, so we don't want the left and the right items to cross. That's what that means, right? So while left is less than right, it always has to be less than. Right. Yeah. So while left is less than right, let's calculate our total. right? And our total at this point is going to be numbers at position left plus numbers at position right, and this is going to be our total. Now we just need to check that if total is equal to our target, that means we've gotten what we want, right? In which case we just return what do we want to do at this point? We just want to return the number, right? And this case that's going to be left plus 1. I don't know why they added this part, like just to increase it by 1. I don't know why, just to trip you up, I guess. But if total is greater than target, like we said, what do we do then? If it's greater than target, then we just need to reduce the right, so we want to move it forward, right? So we just need to do right minus. Otherwise, which means it's less, we're just going to increase the left. So let's say we actually don't have 9 here. Let's say that what we had here was let's see what we had here was actually let's see what we had here was maybe I don't know, 5 plus 7 will give you 8, 9, 10, 11, 12, 12 to remainder 1, 22. Okay, so let's say that our target here was actually 22. Now when we check and we see 15 plus 2, that gives us 17. Now it doesn't make sense for us to reduce our pointer, our right pointer. It doesn't make sense for us to move our right pointer closer, right? It doesn't make sense. So what do we do instead? We move our left pointer to the right, towards the right, right? So that next we have 7 and 15. You get that, right? So we can have 7 and 15. And now that we have 7 and 15, when we check it, 15 plus 7 is going to give us 22. And that's our solution. So, yep. So, that's how you solve that problem. And from this, our space complexity, we're not using any extra space. So our space complexity is O of 1. Our time complexity, we're only, in the worst case, we're going to go through the loop once. So our time complexity is going to be O of n. And now when we run the code, oh, great. Give me a minute. Yeah. So that's what that's going to be. Let's run the code one more time, and that's the solution. Okay, I'm actually going to go through the screen and try to find, before I submit it completely, I just want to make sure. I think we're good. I'll just go ahead and submit. And yeah, that's it. Right, if you liked this, don't forget to like and subscribe. Bye bye.